Hello, geometry students. In this lesson, we're going to be talking about the complement of a set. The complement of the set, it's easier to think of it if you think of it as the completement of a set. So if you look down here at a picture, I've got the set A. The complement of A is basically everything that's not in A. So that's why I have the everything that's not in A shaded. It's everything that's not in that circle. By the way, it's not the same as with an I. That's you're looking lovely today. A complement is, like I said, it's easier to think of if you think of it as a completement. You have everything in A, and then everything that's not in A completes it or makes a complement. Different ways of writing it. You can write it with a little apostrophe. You can put a little tilde in front of it, or you can put a little line over A. They all three mean the same different thing. The same thing. And it basically is everything that's not in A. So look at the Venn diagram. It says in this Venn diagram, these numbers represent the jersey numbers of players that are on the JV team. This is JV. And M is varsity. Not sure who made this Venn diagram, but I don't know why they didn't label it that way. But the first question is saying, give me everyone who is in the complement of L. In other words, give me everyone who is not in the circle L, not in JV. Well, that's going to be basically anyone that's not in this circle. So I'm going to scribble it all out, and all the ones that are left are going to be the people that are not in that L. So we'll make sure you can't see any of it. And so it's just these five numbers: 40 and 90, 60, 80, and 75. That is the complement of L. It's basically everyone who is not in that circle. We'll do the same thing for M. So I'm going to do this. I'm going to mark out the circle M. And my complement of M is basically everyone that I can now see. Everyone that's not in that circle. So it doesn't matter where they are. I've got a total of 7. So 35, 50, 45, 95. The question may be, what do you do about the people who are in both? It doesn't really matter. If you're 30, 25, or 20, you're in M. I don't want you if you're in M. I want you only if you're not. So these three that happen to also be in this other group doesn't matter. How about this last one? I'm not going to worry about the probability because I'm going to do that on the next page. But this is just asking for the intersection of everyone that's not in L and not in M. So the easiest way to do that is scribble out all the L's. That's L complement. Then scribble out all the M's. That's M complement. And basically I want everyone that's left over. So it's the people who are not in these two sets. There's another way of writing this, but that's the way they chose. So that's my answer for that one. And again, I'll be talking about the probability in a minute. But before I do that, let's do some more. You can do a Venn diagram for this one, but it's not necessary. First of all, my universal set is all the numbers between 1 and 10. There are 10 things in that universal set. I'm looking for all the things in the universal set that are not in A. Well, A is 1, 2, 3, 4, 5. So basically all the ones that are not in A, 6, 7, 8, 9, 10. Same thing for B. B, of course, is all the odd numbers, so I want to go back and choose all the even numbers. So 2, 4, 6, 8, and 10. It's when you have these that it's a little bit more confusing. And frankly, I think it might be better to do a Venn diagram. So this is A and this is B. Some of these numbers are used more than once. So 1 goes in both. 2 is just in A, 3 goes in both, 4 is just in A, 5 goes in both. I'm done with the A's, and then I've got 7 and 9. And there's one other number that's not used. So 1, 2, 3, 4, 5, 6, and it's the number 10. Number 10 is not in either group. So if you look at for the union of A prime and B, first thing I'm going to do is I'm going to mark out everything that's in A, because I don't want you if you're in A. But it's a union. So it's basically everyone that's in B or everyone that's not in A. So I got to get rid of that because I'm going to list, the easiest way to do this is to, first of all, just list everyone that's in B. Because if you're in B, you're in this group. The fact that you're also in A is not going to be a disqualifier, but I also want everyone that's not in A. Well, I don't want to list 7 and 9 because I've already listed them once. The only thing left over is 10. That's kind of confusing, but it's easy if you think of it as just saying, first of all, list everyone that's in B. I got those, 1, 3, 5, 7, 9. Now list everyone else that's not in A. Well, that's 1, 3, 5, that's 7, 9, and 10, but I've already listed 7 and 9. The intersection is a little stricter because basically I want to look for all the people that are not in A and that at the same time are in B. Well, the ones that are in B are 7 and 9. The one that's missing is a 1, 3, 5. They're in A. I don't want them. Also the 10, but it's not in B. So a little confusing looking. Look at this next page. It's actually I'm going to be talking about the probabilities. Probabilities of the same thing. So probability is always what you want over total possibility. So I'm going to reach into my universal set and I'm going to pick out a number. There are 10 things to choose from. The probability of me getting something from A is 5. There's a total of 5 out of 10, also known as 5 or 50%. There's a 50% chance that I will choose something from A. How about the intersection of A and B? Well, from my last page, I've got 1, 3, 5, 7, 9, and 2 and 4. And I also had 10 outside. So basically, I'm just going to look for the number of things that are in the intersection. There are 3 things in the intersection, 1, 3, and 5. There are 3 of them out of a total possibility of 10. That's 33 1/3%. How about the intersection of A and B prime? That's what I call the half moon. That means I'm looking at this. I want you if you're in A, but not if you're also in B. So I'm going to exclude people that are in B. That's what the B prime means. When I highlighted that, there were only 2 things. Total number of things I want, 2. Out of total number of possibilities, 10. Continuing on with probability, but not much talking about complement on this. Probability of rolling a 4 on a 6-sided dice. Well, there's 6 sides. There's only 1 4. Don't put 4 up here. That's not correct. It's the number of options I have. And there's only 1 4 on that. So the answer is 1 out of 6. And if you want the decimal for that, kind of over decimals, I really just like the fraction. How about the probability of rolling an even number? Well, there are 6 possibilities. 3 of them are even, 50%. This last one is actually a probability of not 4. And when you have a complement like this, it's easier to just subtract from 1. I don't want 4. So you take the possibility of all of them, you subtract off the probability of getting a 4. which I've already found. I found that in part A. You could also say this. How many things are not 4s? There are a total of 5 of them. But technically, when you do a complement, you should do 1 minus. All right, one more. A box contains 3 red, 5 green, and 2 blues. 1, 2, 3, 5, 5. That's a total of 10 marbles. I want the probability of a green. Well, you reach in, you pull out a marble. There are 5 things that I want out of a total of 10. This is the probability of not red. That means I want to do this as a complement. It's not required, but I'm going to think of it as the probability of 1 minus the probability of red. Well, the probability of red, there are 3 out of 10. You could also do this. Just count up the number of things that are not red, and you get 7. Blue or green? Well, I'm just going to count up the number of things that are blue or green. I've got 5 greens. I've got another total of 2 blues. So 5 plus 2. It's not an accident that these are the same, because these are the same thing. And of course, I like this last one, because technically on this one, I always say you have to add the possibility of all the blues plus the possibility of all the greens. And because this is an and, you have to subtract off the ones that you counted twice. In other words, you have to subtract off the ones that are both blue and green. Sorry. I'm thinking of something different. I was actually leading up to this. How many marbles in there are both blue and green at the same time? Well, that's easy. They're none. That's what I was calling as the overlap. And I was actually thinking about something else. And that's that.